Good afternoon, subscribers. Today we're going to be going over the solutions for quiz 1. So we're now at question 3. We're dealing with parametric equations. Question 3 and 4 are all about parametric equations. So now question 1, we're being given x and then y. X is a function of t and y is a function of t. So these are two. X is independent of y but dependent of t. So both of them are dependent on t. So now we're being told to find dy by dx, and then we're going to prove that dy by dx is equal to x over y. So I've got our x over y, and so now we're going to start. So the gist about parametric equations is that you're going to differentiate when finding dy by dx. You're going to differentiate dy by dt and then divide it by dx over dt. And then this is just basic parametric equations. So you differentiate y with respect to t, then x with respect to t. This is just analogous because what's happening here is we have got dy by dt being divided by dx by dt. So when you want to evaluate this one, you would have dy by dt, and then you would actually multiply it by dx or dt by dx. That is, you would change this to this one is on top, you would bring it down, then put the multiplication sign. This one would cancel out with this one, then you would have your answer to be dy by dx. But you don't have to write this or basically know it. I was just trying to show you where this actually comes from. So now we can start by finding dy by dx, dy by dt rather. So we begin. Dy by dt is equal to, so now here is our y, so now we're trying to use any method that would work, but for this one I would suggest we use the quotient rule. So now the quotient rule says we can find the derivative of a function which is a quotient by getting the derivative of the numerator and multiplying it with the denominator, then subtracting it from the derivative of the numerator by the numerator. So now we can start here. So we have, for y, we have our numerator being this one, so you can write down our denominator, being this one, 2 to the power t. Then we're going to differentiate with respect to t. We're going to differentiate the numerator, which is e to the power 2t minus 1. Then we're going to subtract this from the derivative of the denominator multiplied by the numerator. So we're going to get our numerator 2 e to the power, this one, it's in brackets. Then we're going to differentiate our denominator, which is 2e to the power t. Then we're going to divide it by the denominator, but then we're going to square the denominator. I think you're very, very familiar with the quotient rule. So now dy by dt is going to be equal to, here we are going to have, we just write our 2e, the derivative of the whole function here. Here we're going to use the use substitution. So here we're going to find that it will be 2e to the power 2t. The derivative of 1 is 0, minus e, we can just write this down, 2t minus 1. The derivative of 2t to the power e is basically 2t to the power e, because this one is a constant, so you can remove it. Then the derivative of e to the power t is just e to the power t. So you have 2e to the power t, all are being divided by, we're going to evaluate here, 2 to the power 2 is 4. Then let's not forget also affecting this one, e to the power t times, when you take it to the exponent of 2, we're going to have e to the power 2t. So then we can evaluate this one to find out dy over dt. So dy over dt is going to be equal to, we are going to have, this one here will be 4e, then this power is to the power to the power t, this one is to the power 2t. So we're going to add the powers because we're multiplying. So we're going to have 3t minus, we're going to multiply here. So 2e to the power t times e to the power 2t. We're going to have our 2, our exponent to be here, then because this we're multiplying, the powers will add. So I have 3t. Then now we're going to subtract this one times this one. This one times 1 is just the same thing. Then not forgetting our denominator, which is 4e to the power 2t. So let's go to our next board. So initially we had I think we can just write that down. We had dy by dt being equal to 4e to the power 3t minus 2e to the power 3t minus 2e to the power t, all over 4 e to the power 2t. Yeah. So now we can begin our evaluation. We're having dy by dt to be equal to this multiplication sign is operating on this, is like we have a 1 there. So I'm going to have 4e to the power 3t minus 2e to the power 3t minus 2e. Oh, here is going to be plus because negative times negative is positive, to the power t over 4e to the power 2t. So now we're going to have dy by dt to be equal to there we're going to have when we subtract this one, we're going to have 2e to the power 3t plus 2e to the power t, because these are actually the same things, except the coefficient is the one that differs, but the variables are the same. Then we're going to have over 4e to the power 2t. Now here, since there is a common, there's something in common, we can evaluate by saying dy by dt is going to be equal to we're going to get the 2e to the power t. So we're going to have, in here we're going to remain with e. Since we're going to remove 1e to the power t, we're going to remain with 2e's to the power t. But then there we're going to here we're going to get 2e to the power t, so we're going to remain with 1 over 4e to the power 2t. Then dy by dt is going to be equal to, this one will cancel out with this one, so we're going to have our e to the power 2t plus 1 over, so here we remained with a 2, then we removed 1e to the power t, so we're going to remain with 1e to the power t since there were 2 e's to the power t. So then this is our dy over dt, so we go on and find our dx over dt. So we're going to get another paper to find our dx over dt. So we are going to find dx over dt. So now this one is going to be equal to, change the marker, and this one is going to be equal to, if you remember what x was, we're going to have we're going to write the denominator just as it is, then write the derivative of the numerator, which is e to the power 2t plus 1. Then we're going to subtract it from, well, we are going to write the numerator, and then the derivative of the denominator, which is 2 e to the power t, or divided by this denominator squared. So we're going to have our dx over dt being equal to 2 e to the power t. The derivative of this one are going to have 2 e to the power t again, and then minus this the derivative of 1 is just 0. We're going to have e to the power 2 t plus 1. This one is being multiplied by the derivative of 2 e to the power t is 2 e to the t over 4 e to the power 2t. So now we're going to continue evaluating. Dx dt is equal to, this is 4e, this was 2, so here it will be 3e to the power t, minus, when you multiply this one, you're going to have 2e to the power 3t plus 2e to the power t all over 4e to the power 2t. So now we're going to expand this one. So we're going to have 4e to the power 3t minus 2e to the power 3t minus 2e to the power t all over 4e to the power 2t. So we're going to have dx over dt being equal to, when you subtract here, I'm going to have 2e to the power 3t minus 2e to the power t all over 4e to the power 2t. So then you're going to have your dx over dt. When you factor out, you have a 2e to a t. When you remove, we are going to remain with e to the power 2t minus, here are going to remain with a 1 all over 4e to the power 2t. Dx over dt is going to be equal to, these two will cancel, this one are going to have a 2 there, then this e will cancel out, we're going to divide it, then in here there are 2 t's, so we're going to cancel out 1, then we're going to remain with 1, so we're going to have something like e to the power 2t minus 1 over e to the power t, then there we have the 2. So then we found our dx over dt and our dy over dt. So we have our dx over dt to be equal to e to the power 2t minus 1 over e to the power 2t. Our dy over dt is going to be equal to e to the power 2t plus 1 over e over 2e to the power t. So now to find dx of dy over dx, we are going to have dx dy over dt divided by dx over dt. So this one is going to be equal to, we are going to have, where is our dy there? So we're going to have e to the power 2t plus 1 over 2e to the power t. Then this will divide with e to the power 2t minus 1 over 2e to the power t. So then this is going to be equal to e to the power 2t plus 1 over 2e to the power t, now times 2e to the power t over e to the power 2t minus 1. This one and this one will cancel out. We're going to have e to the power 2t plus 1 over e to the power 2t minus 1. So this is what dy over dx is equal to. Then we're being told to say, the second part of the question, to say we're going to prove that dy by dx is equal to x over y. So now remember what our x was and remember what our y was. It's even shown on the screen. So we're going to have, we've already found dy over dx. So now we can start with this one and say left hand side is equal to right hand side. So on the left hand side we're going to have e to the power 2t plus 1 over e to the power 2t minus 1, which is equal to our x. Our x was e to the power 2t plus 1 over 2 e to the power t. Then this was being divided by e, our y, which is e to the power 2t minus 1 over 2e to the power t. So now since this is the denominator of the numerator and this is the denominator of the denominator, they can actually cancel out. Then we're going to remain with e to the power 2t plus 1 over e to the power 2t minus 1 being equal to e to the power 2t plus 1 over e to the power 2t minus 1. So now you can say left hand side is equal to the right hand side, hence shown. And that's all. You've answered this one. The part that confuses people is actually this one, but this is the principle that I've been talking about, whereby if you have e to the power 2t plus 1 over 2e to the power t being divided by e to the power 2t minus 1 over 2e minus, which is exactly what we have here. This is being divided by this one. We can say e to the power 2t plus 1 over 2e to the t. Then now we're going to put your times e to the power 2t divided by e to the power 2t minus 1. So this is going to cancel out. This one we're going to have e to the power 2t plus 1 over e to the power 2t minus 1, hence shown. So it's a lengthy process, but then some of these procedures are actually not supposed to be here. There are some things that you can actually neglect. Maybe things like this, you can come straight from there to this answer because you know these will actually cancel out. And then there are other simple steps that I actually did only for explanation, but you don't necessarily have to put them in your calculations. So that's all from me. Bye bye. We'll go ahead to question 4 in the next video.